everyone. So we're going to move on to the next topic, which is all about momentum and impulse. We've probably seen it, heard this term before, used it before. Things like, oh, something has too much momentum, or you might say that you had so much momentum that you want to keep going with something. Like I said, you've probably heard it all before. But we want to actually talk about what exactly momentum is, especially in the context of this class. So, momentum is a measurement of the quantity of motion that an object has. The more momentum an object has, the more motion it has, and which means the more force needed to stop it or slow it down. In fact, this is actually very similar to the concept of inertia. If you recall, inertia was a measurement of pretty much how resistant an object is to motion, resulting in the need for a force. This is pretty much very similar, except in the case of when the object starts moving. So, for example, it's referring to not just the mass that's affecting this motion, but also their speed. So, for example, an object that's moving really, really fast, but not super heavy like a golf ball, would have much more momentum than a bowling ball that's not really moving at all. So in that case, the the golf ball, because of its fast motion, would require a lot more force than the bowling ball, just because of its high movement. Now, one of the interesting things here to note is that the symbol that represents momentum is little p. So in this topic, this is one of the few cases, but you're going to see this pop up a lot where we're going to use symbols that don't seem like they really make sense with the measure with what it's representing. Like before, we had force being represented with F, mass with M, R with radius, but now we're going to have P for momentum. And like I said, you're going to see a few more later on. Always use the reference table if you forget. So as we said before, an object that's very massive and fast moving is something that would be harder to stop than something that has low mass or not really moving as much. So the equation for momentum is actually given as P equals mv. This is the equation. P represents the momentum, and m is representing the mass, and v is representing the velocity or speed. Now, the units for momentum, there's two units. The main unit is kilogram meters per second. There is no fancy derived unit. It's just the unit for mass times the unit for speed. You might see momentum measured in newtons time seconds, but this is going to be more used with what's called impulse later on. But for the most part, momentum is just kilograms times meters per second. All right, so here's a practice question. Pause the video, work itself, and we'll go over a second. All right, so we're given two masses, the mass of a car and the mass of a truck, and we're also given the speed that both the car and the truck travel with. So we want to find the momentum of the car, so we do P equals mv. We use the car's mass of 1,000 and its speed of 20 meters per second, and we end up getting 20,000 kilogram meters per second. Truck, same thing, except now we're just going to take the mass to be 5,000 and we get 100,000 kilogram meters per second. That's pretty much it. Here's the next question. Pause the video, work itself. I'll go over in a second. All right. So here they want to know what the magnitude of the block's momentum is. They tell us the time, but that's just a red herring. All we need is mass and velocity. So 5 kilograms and 10 meters per second gives us 50 kilogram meters per second. All right, here's the next one. Pause the video by ourselves. I'll go over in a second. All right, so first thing that I want to know is this. They want to know about the inertia and the momentum of the carts. Now, inertia, if you remember, is mass. So cart A has a mass of 2, cart B has a mass of 3. So that means cart B has the greater inertia. So what we're going to say is we're going to cross out choice A and choice B because they say that they have the same inertia. So now we have to compare their momentums. So momentum of cart A, 2 times 3 is 6. cart B is 3 times 2, which is also 6. So they have the same momentum. So the answer is D. All right. One thing I want to point out really quickly, I had hinted and said this before when I talked about inertia, that the Regents is going to commonly kind of relate this back to inertia, where they're going to give you a bunch of speeds with masses. This is why. Inertia and momentum have very similar definitions. They are fairly well related. Uh, you just need to remember that inertia is mass and try not to get caught up in automatically multiplying mass and velocity to find the momentums. Here's the next question. Pause the video for itself and we'll go over in a second. All right, so as the object's falling towards the Earth, it wants to know what happens to the momentum. So remember, the momentum equation is P equals mv. So we have to look at what's happening to both the mass and the velocity. Now, the mass doesn't change as the object falls. The mass stays the same. So we have to compare the velocity now. As the object falls, it gets faster and faster. So since the velocity increases, that means the momentum increases. Both momentum and velocity have a direct relationship. So when one increases, the other one also increases. Here's, I think, the last question. Pause video work itself and we'll go over in a second. All right, similar thing. Here we have two objects being dropped from the same height and we want to compare the momentums. Now this time when we drop the two objects, because they're both being affected by gravity at the same time of fall, their velocities will end up being the same. So the velocity is not going to be the factor that we look at. Instead, we're going to look at the mass. So 5 newtons and 10 newtons, they have different masses. In fact, the 10 newton mass has the higher, or the 10 newton object has a higher mass. So what we're going to say is that their momentums will end up being different because their mass is different. One thing I want to point out though is you can't just look at one variable, see how that changes, and then say that the other one's going to change. You do have to look at both, because if they had a scenario where they had different masses and then they fell for different amounts of times and their speed's different, because that might end up one might end up being bigger and the other one actually smaller, could end up canceling out such that the momentum doesn't change. So you need to look at what's going on with both variables. Typically, though, in a lot of these cases, only one's going to change, and then you could just look whether they have a direct, inverse relationship, exponential, to see how it's going to change. All right, and that's pretty much it. If you have any questions, feel free to let me know. Otherwise, I'll see you later. Good luck and have a great day.